Hello, and welcome to this video on Chapter 21, Periodic Motion. Okay, so what do you need in this video? Okay, you need your worksheets and part of Chapter 21. We're just going to discuss one of the paragraphs. And what are we going to learn in this video? We're going to learn about the period, frequency, amplitude, and a graph of a vibrating spring. Okay, or rather a mass on a spring which vibrates. Yeah. Okay, so this is a picture at the top of one of the paragraphs, so look for it in your notes. Yeah. Okay, so let me explain one of the snapshots. Okay, so snapshot number 1 is that spring is at rest. Okay, it's just hanging from the ceiling at this position. Snapshot number 2, the spring is pulled down from O to A and then released. Yeah, so it's just been pulled down to A and it's going to be released after that. Then, as you have seen from the animations before this video, okay, the spring will then travel back to past its rest position to the other side, back to its rest position, and back to its initial position. Okay, so these are 5 snapshots of what is happening. So spring is pulled down here, it travels up here, back to its other maximum, back to its rest position, and comes back to the original position 1 cycle later. Okay, so there are a few things that we also need to explain. So we define the distance traveled by the mass from its rest position to be y, and we take this level, the rest position, to be y equals to 0. Okay, and then the spring gets pulled down to level A. Okay, and since we define downwards taken as positive, so from O to A is a positive distance. Okay, so O to A is a positive distance, so this mass here is at a positive value of y. This mass here is at a value of y that's 0. This mass here, okay, this mass here is at a value of y that is negative. Okay, this mass here is a value of y that is 0, and this mass here is a value of y that is positive. Yeah. Okay, so that's how it goes when we define downwards as taken as positive. Right. So now, okay, so. And as you probably realize, okay, the amplitude is the distance from its rest position to its maximum. So there are 2 maximums, one at the bottom and one above. Okay, so the amplitude is just the distance from the y equals 0 to its maximum here. So same thing, you can also define the amplitude as from y equals 0 to its maximum here. So it's also this distance. Okay, and we see that from the graph. Okay, its amplitude is from the distance y equals 0 to its maximum is y equals to 1, so the amplitude here is 1 cm. Okay, so now let us match the snapshots to the graph. Okay, so initially you snapshot number 2, you pull it down, okay, and it's at its maximum, so it's at a maximum value of 1. Okay, and you release it. Then once you release it, it travels to O, so it's here, it passes through the rest position, which we define as y equals to 0. Then it travels further to its other maximum, which is now at a negative value of y, which is negative 1. And come back to its rest position at the snapshot number 5. Okay, and it carries on to its original position at snapshot number 6, which is exactly the same as snapshot number 2, and the whole thing repeats itself. Okay. So this is the graph of the snapshots, yeah, and then of course this is you would have seen this graph in a previous video. Okay, and of course this graph tells us the amplitude because the distance from the rest position to its maximum is 1 cm. Okay, and you can also see the amplitude below, the distance from 0 to its other maximum, also 1 cm. Although, yeah, we take the absolute value from here, 0 to 1. Yeah. Okay. Right. Okay, so that is the graph of this periodic motion. Okay, and then let us understand this graph better. Okay, so we have established that this graph tells us that the amplitude is 1 cm, and that was because the spring was pulled down 1 cm and then released. Okay, so if you pull the spring down 2 cm, then we will expect to see that the amplitude is 2 cm. Okay, right. Period is the time taken for 1 cycle. So as you see, the time taken to get from 2 back to 6, which is the same as 2, is actually 1 second. So 0 to 1. So in this case, the period is 1 second. The frequency is the number of cycles per second, which is 1 divided by the period. the unit of frequency is hertz, which is actually cycles per second. So since we have one cycle taking 1 second, so in this case the frequency is 1 hertz. Okay, now suppose the period is 0.5 seconds. So in 1 second you will see 2 cycles. Yeah, so the frequency, if the period is 0.5 seconds, then the frequency you will see is 1 divided by 0.5, which is 2 hertz. Alright, so this is the end of the video. We have learned about period, frequency, amplitude, and then this is the graph of an object vibrating on a spring. Okay, lastly, you will notice that this looks like a cosine function. Yeah, okay, so this is the end of the video.